Hi, I'm Patrick Geary, and this is video prompt 1 for Psychology 3411. So scientific thinking is the thing that helps us understand the world to some extent. The thing that sets it apart from pseudoscience or any just general ideas is that it has an established set of rules. And these rules are empirical, so what you're doing must be observable and measurable. And generally that means in your experiment you need an independent variable, which is the thing that you'll be manipulating, and a dependent variable, which is the thing that you'll be measuring. It also needs to be falsifiable, and this is important in a scientific study because allowing yourself to be wrong is an important part of science. Like, if you've got a theory and it's disproven, that doesn't mean that it's a failure. The point of a scientific study is not to prove something right. It's to try to get the answer to a question. Sometimes that answer is no. Provisional as well, that's the last step here, is it has to be able to be changed. Science is fluid. Sometimes with new information or new resource gathering materials, a theory becomes dated, and in that you have to change. Pseudoscience being different from actual scientific method. Pseudoscience tends to make guarantees. Like, it'll say something along the lines of, science guarantees that this will happen if you do this, and that is not what this is about. Science, again, is asking the question, and is not afraid to have the answer be no, or this is wrong. Steps of the scientific method. So first you observe something, and it could be something interesting or just like how things interact with each other in an environment. It leads you to a question, and you ask this question, and this will be the basis of your research, is trying to figure out the answer to this question. The next step would be a literature review. So you go back and look at people that may have done research on something similar, or asked similar questions to what you're trying to ask or answer. So you have to go relatively in depth to understand that. Dig into the research that's been done before you. Then you come up with a hypothesis, and this hypothesis is basically just a prediction of what you think will happen in your research as you're trying to answer this question. Next is the longest and probably most difficult part, which is collecting data. And the way you collect this data will be different depending on what your research method is. Descriptive, correlational, experimental. But regardless, it's not always easy, but a lot of times it'll be through like self-report, or I don't know, there's a whole bunch of different ways in which you can gather information, and all of them are relatively tedious. Next, once you have your information and your data, you need to analyze the data. So you want to plot like what the data is on a data point, be it through like some sort of tables, generally into a graph of some sort, and it allows you to pinpoint trends and to compare results, basically. After that, the data will lead you to a conclusion, and that's an important part here, is that you're not trying to make conclusions based on what your hypothesis is. The data will tell you what is actually happening and what the answer to your question is. And as you get that conclusion in the data, you are obligated as a scientist to share that information with the community, normally through like journals or speaking or something along those lines. And this kind of leads us directly into the idea that in science, you're building upon knowledge. So disproving a theory still gains knowledge. And that's the thing, is technology changes can lead to new collection methods and new studies, and that can disprove an old theory. But that old theory was still a starting point. And theory changes are an important part of science, and that's part of the provisional nature of it. I think that I've droned on long enough. Anyways, thanks for listening to me, and I actually really like the Cambridge course sci stuff, so look forward to doing a few more of these with you. Thank you.